Hello everyone and welcome to another Scratch tutorial, and today we're going to be talking about our logical blocks, which is math. Okay, so math is a very important part of any game, and it's not just math, it's logic, right? So think about it like this. Okay, I'm in a room, okay, and inside the room there's a door. Now if I walk towards the door, what's going to happen? I'm going to go outside the room. That's the end result of my decision. But let's say I don't walk out the door, right? What's going to happen? I'm just going to stay in the room. That's the output of my other decision. So that's what games are. It's all about making decisions. And computers can't make decisions for themselves, so we have to give our computer a sort of a direction on what they're supposed to do. Like let's say, this is what we're going to do. We're going to make this sprite move when we click on it. Okay? But once it reaches the edge, we're going to make it flip. I'm going to make it flip in the other direction and then make it move. Now I already know there's already a keyword called if on edge bounce, but I want to show you how that keyword works. Okay, so we go to control, and this is the logic I was talking about. We have if something happens, then we move, right? And then its cousin. If something happens, then we move. Else, that means we're on the wall, we bounce, or something like that, right? So these are called decision blocks, and you'll be using them a lot, and you'll see how they'll be used in future projects. So when sprite is clicked, we're going to drag in this if block, and we're going to go to sensing, which we haven't taught you yet, but we will. And we're going to say if touching edge, what's going to happen? Let's just say nothing happens for now. Okay, so let's say we didn't have this. What would happen when we just move 10 steps? Okay, as you can see, we just go off the screen, but we don't want that. We want it to bounce. So once we add this, let's put our move 10 steps right here. Once we reach the edge, so right now it's not touching the edge, right? Meaning that we're in our else condition. And our else condition is basically stating that we move 10 steps. But once we touch the edge, once we're touching the edge, now this is true. This statement is true, meaning that the statement inside the if runs. We don't have anything yet, but let's add that code. Okay, and it's very simple. We're just going to turn 180 degrees. 180 degrees, and we're going to move 10 steps. Okay, so let's try it. Okay, I'm just going to move this. As you can see, now our character won't go off the edge because we have this decision-making tree right here. Okay, it's a very simple one, but it is a tree nevertheless. Now, I did tell you there's going to be some math in here, so let me show you what I mean by that. Okay, so let me remove this. This is called a Boolean statement, okay, which basically means a true or false statement, right? This will return either true or false, and depending on if it's true or false, if it's true, then the thing underneath the if condition, like right here, sorry, oh god, this block right here will run. But if it's false, then the block underneath it will run. And that's what these pointy edge things are. Hexagons, whatever they are, you know. But right now I'm just going to remove this stuff, and I'm just going to add change x by 10 and change x by negative 10. So if you remember what this means, is if we change x by negative 10, we move in the left direction. If we change x by 10, we move in the right direction. Now I'm going to do a quiz, okay? Or actually, let's make this a bit better. Let's add a point in direction, 180. Oh, sorry. And point in direction 90. Okay. and I think I mixed that up here. So right now, let's just say if touching edge is true, okay, like we did before. As we move, we are moving left because we're not touching the edge. But once we touch the edge, we move to the right, remember, to point in direction 90, and we change our x by 10 since we were touching the edge. Now, I'm going to give you a little bit of a math problem, okay? So this is very simple math, but let's see if we can solve it. Now we're going to go into the operators block, and we're going to look at all of these, okay? First, we're going to look at the equal sign. Where is that? Right here, okay? And then our plus sign. So as you can see, these circular things are basically values. They're values, right? So let's try this, okay? 5. Does 3 plus 2 equal 5? If it does, then we should move right. If it doesn't, then we should move left. Well, as all of us know, 3 plus 2 does equal 5, so we should move to the right. Does 3 plus 3 equal 5? As we all should know, it doesn't, so now we'll move to the left. And let's do a few more problems like this, okay? So instead of 3 plus 3 equals 5, let's do subtraction. Does 6 minus 3 equal 5? Nope. Does 6 minus 1 equal 5? Yup. Okay, and as you can see, multiplication and division, same thing. Okay. Now here's a cool thing, okay? We don't have to use the equal sign, we can use the greater sign, right? So let's say we're comparing something, like we're comparing, like, is this character greater than a certain x position? Is this, like, let's say we have a finish line right here, right? And if the character passes the finish line, if the x is greater than, like, let's say 200, then he wins. So 200, if character position, let's see, if x position is greater than 200, or let's say 100, right? Then we're going to change our x by this direction. So let's see. Since the x is not greater than 100, we're not doing it. But as we put our character here and we move, we're already past the finish line. So now our x position is greater than 100, and therefore we're moving to the right. And honestly, it would make more sense if we flip them. Like if you said if it's less than, right? Because, so let's change this. And if x position is less than 50, then we should move towards the start line. If it's not less than 50, we should move backwards. So let's see how that works. So we're going to 50, and now we switch. I think we're probably stuck because we have to change our x by a much greater value. But you see how it works, right? So that's what the greater than sign is used for. Here's another cool thing you can do. 5. Let's say you want random values, okay? And this is a cool thing right here. So in the future, we're going to be probably teaching you how to make a catch your apple game, right? Where the apple goes in random positions. So we can use this pick random from 1 to 10. And this basically is giving us a 50% chance, because remember, there are 5 numbers that are, sorry, it should be 6. There are 5 numbers that are less than 6, and 4 okay, that's weird. Let's do it 0 to 10, and then let's make this 5. Okay, now this makes sense. There are 5 numbers greater than 5, and 5 numbers less than 5. So we have a 50% chance of moving left or right. As you can see, that kind of makes sense. If you have a 50% chance, then we'll be moving left and right like around the same equal time, right? So pick random is very useful, especially when you're moving to like random x positions or random y positions. Okay? Here's another cool thing. You can combine conditions. Yep, that's right. if 2 plus 1, oh, oops. Okay, if 2 plus 1 is less than 5, and 10 minus 5 equals 5. So let's see, let's see if this is correct. Is 2 plus 1 less than 5? 3 is less than 5. 10 minus 5, is it equal to 5? Yes, it is. If you combine these two statements, right, and if you put it here, since both of these statements are true, we'll move right. But if even one of the statements in an AND condition are false, 2 plus 6 is 8, which is not less than 5. Even though 10 minus 5 is equal to 5, if even one of the conditions aren't true, then we go to the else, meaning that this is false. Okay. Now we also have an OR condition. So let me show you what that does. Oops. So remember, one of these conditions are false and the other one is true. If we use OR, this is basically saying, even if one of the conditions are true, right? Like let's say we have 2 plus 6 is 8, right? Which is less than 5. That's false, but at least this is true. We'll still move right. The only way you won't move right, meaning you'll move left, meaning it's false, is if both conditions are false. 10 minus 4 is not equal to 5. 2 plus 6 is not less than 5. We'll move left. Now, if you don't get this math, make sure you kind of understand it, right? Pause the video and make sure you understand. So let's put this right here. And then we have a nice thing called not. Now these things right here are useful, but we're not going to teach them because they are a tiny bit complicated. So this is all you need to know from here. Just the first 4 sections right here. Okay, but make sure you know them well. Not, okay, we're going to use the not block. 5 plus 5 equals 10. Okay, so 5 plus 5 equals 10, which is true. But the cool thing about not is that it flips our answer. So true becomes false, false becomes true. Okay, now you might be asking, why is that useful? Well, let's say that we're checking to see if a value like is not equal to something. So like, let's say 5 plus 5 is greater than 10. I think that's a better thing, right? If the x value is greater than 10, yeah, let's do that. So x position greater than 10. Where's the greater than sign? Right here. If not x position is greater than 50 is the same thing as saying if x position is less than 50, right? So it's just a nice way to, you know, flip true and false, and you'll see why it's useful later on. But hopefully you understand all of these blocks and you understand the if and else statement. That's important. I know this video has been long, but if you understand the concepts, you will get far in your projects. This is a fundamental part of Scratch. I'll see you guys later.